Well, hello and good morning, Algebra 2. It's Mrs. Klein, and as sometimes happens, I need to be out today unexpectedly. So I will walk through your tasks for today and teach you how to use Desmos on your own so that you can find some trend lines and some correlation coefficients. You have the class notes for today, day 7. We'll look at some data here real quick and I'll help with the Desmos tutorial. So grab a pencil. Grab your notes. Here we go. So you're looking at a scatter plot here, and it's using the commute times that you guys entered from your survey last week. So you can see here on this axis, this is how far away you are from school, and then this is how long it takes you to get to school, you being you students. So go ahead and draw your own estimate for the line of best fit. So you put something on the graph that looks like a line of best fit, and don't forget this outlier. Did you do it? Don't just wait for me. All right, good. I would put something maybe like this, because I have to consider that outlier. Maybe you did something different. Estimating a correlation coefficient for this data is going to be interesting because of that outlier. It looks sort of upwardly liney, but not very well. I might call that R is about equal to maybe 0.5. Maybe you picked something different. Identify any outliers. You go ahead and do that. That's the outlier right there. Okay, and then we're going to use our trend line and we're going to start to make some guesses. So we need to talk about two really important vocab words: interpolate and extrapolate. Interpolate sounds like a great word. I'd come up with a joke, but it is 5:30 in the morning, so sorry, no joke today. Interpolate means we're going to predict within the data. So we're going to ask maybe how long would the trip take someone who lives 5 miles away, and we pick 5 miles because we have data for 10 miles and 0 miles, and 5 miles is in between that. So according to our trend line, if somebody lives 5 miles away, it should take them around the neighborhood of 25 minutes to get to school. So that's interpolate. You hear the word inter in there. It means inside the data we have, in between 0.1 and 10. That's interpolate. Now, extrapolate, hear that word extra? Extrapolate is kind of the partner to interpolate. Interpolate was within the data. Extrapolate is outside the data. So this number here, 15 miles, is not in between 0.1 and 10. 15 would be out here. So since 15 is not in between data points we have, if we're going to try and figure out how long it would take somebody who lives 15 miles away, that's extrapolation. It's extra. So again, we could look at our trend line, and we might have to make some guesses here because our graph only goes up to 10. So 15 might be here. If we extended that line, we might be up here. Here's 50. Maybe that's 65. Maybe. I don't know, you might say 60, you might say 62 and a half, but it's 5:30 in the morning, so we're going to go with 65 minutes. Would be an extrapolation roughly based on the data we're looking and the trend line we drew. Now, you might look at this and say, 15 miles away is not going to take me 65 minutes to get to school. Okay, we're just using the data and the trend line to extrapolate here. So you might feel different. So flip the page over and jot down a good definition of what interpolation means and a good definition of what extrapolation means. So interpolation means making a prediction or a calculation using a data input, or you might say something different, but you'll say that is between or inside the given data set. Okay, so you might say something thing slightly different when you write your answer or your vocab definition here, and that's just fine. Also give yourself a definition of extrapolation. So extrapolation means you can write this: prediction using a data input that is not in between the given set or is outside the given set. Okay, so interpolation and extrapolation are two words we're going to throw around the next couple of days, and you are going to have to know them. So feel free to go back to this video and watch it again if you want. We are going to show you how to do this in Desmos now, so that you can make Desmos find a line of best fit and get a correlation coefficient and all that great stuff. We'll also come back and do some inverses here in another video.